Hello. Today we are going to be continuing evaluating functions, but we are going to add a special little step to it. We're going to be evaluating piecewise functions instead of just basic functions. So without further ado, let's investigate and let's learn about what piecewise functions even are. So this is what a piecewise function looks like. Maybe you've seen it before, maybe you haven't. Maybe you're thinking to yourself, this looks a little bit like a system of equations. It does, a system of equations, plural. It does. It is two equations that form together to make one equation, one function, whereas a system of equations are two equations where you're looking for the one solution that makes both equations true. But still, the fact that it has two equations inside of it does make it similar, but it does have something else added to it. It has domain restrictions. So we see that x squared plus 3, comma, x is less than or equal to 2. Then we see negative x plus 7, comma, x is greater than 2. So that's the special part of piecewise functions. A piecewise function is one function. It's multiple functions that form together to make one function because they're defined differently. The function is defined differently over its domain. So it has one set of domain, so in this case from negative infinity to 2, that is defined in one specific way, which this case is x squared plus 3. Then it has another section, anything after 2, all the way to positive infinity, that is defined as negative x plus 7. So sometimes piecewise functions may have 3, 4. I mean, they could really have as many as it needed. It doesn't just have to be 2. But there will always be domain restrictions following each function. Okay, in order to evaluate piecewise functions, we have to be very, very careful. You have to look at those domain restrictions, those domain specifications, to ensure that you are evaluating in the correct portion of the function. So let's look at it. Let's see what all this means. So we're going to evaluate a piecewise function. This is the same piecewise function from the previous page, except this time we're going to actually evaluate. We're going to say f of 1. But we see two functions. We don't need to plug one into both functions. We only need to plug one into one of the functions. But which one's the right one? Here's your question. Is 1 less than or equal to 2, or is 1 greater than 2? 1 is less than or equal to 2. So that means we need to use x squared plus 3. So we're going to say 1 squared plus 3 is 4. So just like that. Let's do another one, f of 5. So once again, we have to ask ourselves, is 5 less than or equal to 2? Or is 5 greater than 2? In this case, 5 is greater than 2. So we have to use the second portion of the piecewise function. We have to use negative x plus 7. So negative 5 plus 7, which is 2. We're going to continue doing the same thing. We're going to evaluate the function. This time you're going to try it yourself. It's the same function, but this time I want you to evaluate f of negative 1. You have 30 seconds. Begin now. All right, 30 seconds, it flies by, doesn't it? Okay, we know that negative 1 is less than or equal to 2. It is less than, not equal to, but that's the restriction it falls within. So we need to evaluate for x squared plus 3. So negative 1 squared plus 3 is going to be positive 1 plus 3. And the reason why I chose this is to make sure that you remember that anytime you square a negative number, you have to put it in parentheses if you're going to use your calculator. But once again, remember, your best calculator that you have is your brain, because your brain would tell you it's positive. Calculator, if you type it in wrong, will tell you it's negative. So you're going to get 4. Okay. Hopefully that's what you got. Let's keep going. We're going to still evaluate piecewise functions. We have 2x squared plus 3 when x is less than 3. And we have x plus 4 when x is greater than or equal to 3. Let's evaluate it for 5. Is 5 less than 3? Or is 5 greater than or equal to 3? 5 is greater than or equal to 3. So we have f of 5 equals 5 plus 4, which is 9. Still evaluating piecewise functions. You're going to try it yourself. Same function, f of -2. You have 30 seconds. Begin now. Okay, time's up. -2, is it less than 3 or is it greater than or equal to 3? It is less than 3, so we have to use 2x squared plus 3. Once again, remember, if you're squaring a negative number, it must be in parentheses and if you're going to use your calculator. -2 squared is going to be 4, and 2 times 4 is going to be 8, and 8 plus 3 is going to be 11. Okay, so now we're moving kind of away from piecewise functions and we're adding back in to evaluating functions. So this is going to be a little bit more work, but you can totally do it. We're going to evaluate g of x. So we have, not evaluate. We have g of x is defined as 8 plus the square root of x plus 4. You're going to use g of x to simplify g of x minus g of 5 all over x minus 5. So we're going to make a longer expression based off of this. So the first thing we need to do is evaluate g of 5. So g of 5 is 8 plus the square root of 5 plus 4. The square root of 5 plus 4 is the square root of 9, and the square root of 9 is 3, and 8 plus 3 is 11. So that was everything that we did in the evaluating functions video, the previous video, and you already know how to do that. Okay, so now we really need to start looking into this g of x minus g of 5 all over x minus 5. So the first thing is that we have a g of x. So we know that g of x is defined as 8 plus the square root of x plus 4. The next thing we see is a minus. You got to make sure you include it. And then we have g of 5. But we know what g of 5 is. We know it's 11. So we're going to place it there. And then we're going to have it all over. And we're going to bring down that x minus 5. Is there anything that we can do to simplify this function? Yes, we can combine 8 and our negative 11. I don't know why the negative is not in that circle. I apologize. So 8 minus 11 is -3. And we're going to bring everything else down. Okay, now one thing I do want you to know is that you cannot square root that 4 because it is part of an addition problem. X plus 4 all becomes one number at some point, so you cannot square root part of that number. It's not legal, so don't do it. But other than that, hopefully you wouldn't try to square root an x because it doesn't have a square with it. But just be careful not to try to square root part of an addition or subtraction problem. That is not allowed. All right. Hopefully this video helped with you evaluating piecewise functions and evaluating a more complicated function. I hope to see you next time.